Hi. What we're going to look at in this video is another example of applications of derivatives of sine or cosine functions. Now, this is from an example in the text. I think it's on page 198 or 189. Anyway, what we have is a population of frogs according to time, where the time is in months. The first part of the question is really easy. It's asking for the population at the beginning of 0. So at this time, the time is going to equal 0. So for part A, it's very easy. All we need to do is substitute 0 in for t. So we've got 100 sine pi times 0 on 2 plus 500, which equals 100. Anything times 0 is 0 times sine of 0 plus 500. Now for this, all I need to do is just think of my unit circle. Okay, at angle 0, remember on my unit circle, my sine value is found by my y coordinate. So my y coordinate here is 0. So this whole thing is going to be 0. So my population at time 0 is going to be 500. Now for part B, it's asking for the first time the population is a maximum. Now we're going to look at this in a couple of ways. We're going to use differentiation, and then we're also going to verify this by using our knowledge of what a sine graph looks like. We could also verify it by doing values either side of it or doing our double derivatives, but I'm going to choose using our sine values. So the first thing I want to do is actually want to have a look at what my graph's going to look like. It's always nice to get an idea of where you're going. So if my x value is my time and my y value is my population, I can see that it's going to oscillate around 500. So if I'm thinking of my format of y equals a sine bx plus d, this gives me my vertical shift. So it's going to oscillate around this value of 500. My a value gives me my amplitude. So it's going up 100, down 100. So it's going to go up to 600, down to 400. So the population of my frogs is going to change like this. It's going to go up 600 to 600, down 100 to 400. So what I'm looking for is asking me to find the first time the population is at a maximum. So it's not asking me for what my maximum is. I know that's going to be 600, but it's asking me for the time that it is. So first of all, we're going to do this using differentiation. Remember, differentiation gives us the rate of change. So at a maximum point, my derivative is going to be 0. At a minimum point, my derivative is going to be 0. So let's have a look. So if my population according to time is 100 sine pi t on 2 plus 500, then my derivative is going to be, if I derive that, that's going to be 100. Now think of it, I've got a function within a function, so I'm going to derive the larger function first. So it's going to be sine of whatever inside the brackets. So the derivative of that's going to be cos pi t on 2 multiplied by the derivative of whatever inside my brackets, which is pi t on 2. So the derivative of that is going to be times pi on 2. Now the derivative of 500 is going to be 0. So I end up with 50 pi cos pi t on 2. Sorry, that's a pi. Now I need to know, for my maximum point, I need to know when that derivative, the equation of my, the gradient of my tangent is going to be 0. So when that equals 0, so I can divide both sides by 50 pi, and so I end up with 0 equals cos pi t on 2. Now this is my angle, so I need to know at what angle the cos of that's going to equal 0. So same again, if I'm looking at my unit circle, my x-coordinate provides me with my cosine of an angle. So my cosine is 0 at pi on 2 or 3 pi on 2. Now when I'm looking at this, I know that's going to be maximum at my first points. I'm going to look at pi on 2. So pi, therefore, pi on 2 needs to equal pi t on 2. So therefore, t is going to equal 1. Now my next stationary point is going to be when t equals 3. Now I know from looking at my graph that my first one's my maximum, my next one's my minimum. Now I could look at the slopes either side, I could do the double derivative to verify that. But what I'm going to do instead is I'm going to have a look at another way that we can justify this value. So let's look at another way that we can verify our value that our maximum occurs at time 1 month. Remember our units for time was month. Now we know we've got a sine graph. There's no lateral shift, so it's a nice, fairly straightforward shape. It's been vertically shifted 500, so it's oscillating around the point 500. Now what we want to know is we know that it does a full cycle here. Our first maximum point, our midline point, and our minimum point. So our first maximum point occurs a quarter along the way of our full period, okay? Because that's our halfway point, and that's a quarter of our way point. So if we can find our period, we can find the time for our first maximum. So remember, our period can be found by 2 pi divided by b. Now in this case, b is pi on 2. So our period is 2 pi divided by pi on 2, which is the same as 2 pi times 2 on pi. So our pi's cancel out, so our period is 4. Remembering our unit are months, so our period is 4 months. So if we know that this value here is 4, then it's gone back to our midline point at 2, it's reached its minimum point at 3, this makes its maximum point at 1 month. So we've also been able to verify that our first maximum occurs at 1 month. Okay, so you can verify it by doing the double derivative, you can verify that by looking at the slopes either side, and you can also verify and calculate it by looking at our knowledge of periodic functions.